Okay, so in this video, we've been presented with this equation. We've got Al plus HCl produces AlCl₃ plus H2. And effectively, we've been asked to balance this equation by putting numbers in front of it. And in our final equation, we need to have only whole numbers in front of our values to effectively balance the equation, right? Okay, so how am I going to approach this? Well, the first thing I'm going to do when I'm looking at this is I'm going to take effectively an audit of what do I actually have in front of me, and I'm going to consider this in the context of the left hand side, right? So this is the stuff on the left hand side of the arrow, so Al, the HCl, and I'm going to consider also in the context of the right hand side, so the things which are on the right hand side of the arrow. And so let's do that. So this is effectively an audit of the initial atom count, right? So if we now consider, so left hand side, okay, so we've got Al, we've got H, and we've got Cl, okay. So if we look at this, we can quite clearly see we've got, for Al we've got 1, for H we've got 1, for Cl we've got also 1, okay. And now let's consider it in a context of the things on the right hand side of the arrow, right? So we're going to just put there RHS, so right hand side, and so we effectively lay out the same elements, so Al, H, Cl. And if we do the audit on this side, for Al we've got, okay, we've got 1, for H we've got 2, right? And for Cl you can see you've got 1, 2, 3, so Cl3, right? So put 3 here. And as you can see, okay, so the Als are effectively at this stage, they seem balanced, but we've got we don't have an equal number of hydrogens, we don't have an equal number of chlorines, so we can reasonably say, well, at the moment it's not balanced, right? We need these numbers to be effectively the same regardless of what they happen to end up being at the end, so which is not the case. So what I'm going to actually first consider is the inequality between the Cl, right? Because you can quite clearly see on this side we've got Cl3, right? And here we've got only a Cl. And if we wanted to make that equal, more or less there's only one way to do that, right? Or one of the primary ways we can do that within the context of trying to really focus on getting whole numbers at the end would be, well, I'm going to put a 3 in front of the HCl, okay. And so when we do that, this is the equation that we're going to get. So we're going to get Al plus 3 HCl produces AlCl₃ plus H2, okay. So this is effectively the equation we get when we do that. And I'm now going to do an audit again, okay. So when we do the audit again and we consider what we've got at the end of this, so left hand side, Al, H, Cl, you can see that we didn't put anything in front of the Al, so it's going to be the same. We're going to have 1 Al, right? But for the H, you've put the 3 there, so we're going to have 3 of those, 3 H, and Cl again we put the 3 in front, so we're going to have 3 Cl, okay. So it's 1, 3, 3. Now if we consider now the right hand side, yeah, Al, H, Cl, right? What we're going to find is effectively going to get, we didn't change anything, right? So we're going to just get the same as what it was before. It's going to be 1, 2, 3. But now if we compare left hand side and right hand side, we'll find that now the Al and the Al on both sides, left hand side and right hand side, are balanced. The hydrogens are not balanced, but the chlorines are balanced. Okay, so we've now got a situation where we at least have some level of balance between everything except for the hydrogens. And what we notice when we really look at this equation and say, okay, well, the hydrogens are now an issue. How do we get it balanced without creating needless complications? Well, on the right hand side, we actually have a H2 on its own. So that's kind of a ripe opportunity to actually, well, try and get some balance in the equation. So what effectively I'm going to do is, you could call this an intermediate step, because the main objective here is to get the two sides balanced, and considerations about achieving whole numbers, etc., is going to be dealt with at the end. Okay, so what I'm going to do is I'm actually going to put a 1.5 in front of the H2 on the right hand side. Okay, and so I'm just going to write out what the new equation looks like. Okay, so that's going to be Al plus 3 HCl produces AlCl₃ plus 1.5 H2. Okay, now within the context of this, if we do an audit now, what are we going to find, right? If we do an audit here, so again, we're going to do left hand side and right hand side. So on the left hand side, AlHCl, again, we're going to have 1 here, and as you know, we didn't change anything in this iteration, so this is just going to be the same as what it was before. So it's going to be 1, 3, 3. We changed on the right hand side the hydrogen, right? We didn't change anything with regards to the Al or the Cl3. So AlH. So I'm going to deal with the Al and the Cl first on this side. So it's going to be simply the same, right? So it's going to be a 1, and for Cl it's still going to be a 3. But for the hydrogen, because I put the 1.5 in front of the H2, effectively, you know, if you multiply 2 by 1.5, of course you're going to get 3, right? So, you know, see, if you get 3, like if you have 3 over 2, which is the same as 1.5, you multiply that by 2, right? Of course, you know, you just cancel out the 2's. All you get left at the end is 3. So similarly here, simply going to have a 3 at the end, right? And if you now compare the left hand side and the right hand side, you know, you've got 1, 3, 3 on this side, on the left hand side, and you've got a 1, 3, 3 on the other side, the right hand side, right? And so we can say that now it's balanced. However, if we really pay attention to the question says, please use only whole numbers when balancing the equation above, right? So in our final answer, we actually need to make sure that we're dealing with whole numbers. So for this, in this case, in order to make it whole numbers whilst keeping it balanced, what we simply need to do is we need to double everything. If we double everything, that is going to be, you know, it's going to be balanced, right? So or it's going to be balanced and it's going to be whole numbers. It's already balanced, but when we double it, we're going to have all whole numbers and it's going to be balanced, right? So effectively, if I put that equation out there now, so if we start with this Al, it's going to be simply 2Al, and if you start the 3 HCl, so that's going to be instead it's going to be plus 6 HCl, right? And here we've got AlCl3, so instead it's going to be 2 AlCl3, okay, and 1.5 H2 is instead going to be plus 3 H2, okay, right? And if we do a quick audit again, it's very straightforward. I mean, at this stage, all we're doing is doubling everything. So it's literally just double everything we've got here. So Al is going to be 2, H is going to be 6, Cl is going to be 6, Al is going to be 2, H is going to be 6, Cl is going to be 6. Okay? So in this particular case, the balanced equation, whilst also adhering to this whole number policy, is this equation. Okay? So that would be our balanced equation. So 2, 6, 2, 3, right? So if we refer back to the question, we can reasonably say that it's going to be, just as we did, it's going to be 2, 6, 2, 3. Okay?